Okay, students, good morning. And today's session we are going to discuss about this the best first search. So how we are going to discuss the concept for this the best first search. Best first search is a combination of depth first search as well as the breadth first search. So here we are going to do that. So how we are going to do this? So we are going to discuss in this methodology. So here we just introduce one notation that is called as an R graph. The notation of the R graphs is required to avoid the revisiting of the paths. So there is no need to propagate back to the successor if it is required also. So here how we are going to proceed with this algorithm. Okay, so that is another one more the important information. So first one is a description of the states, description of the yes, description of the states. If it is required, indication how promising it is. Another one more thing is parent link that points to the best node, and it has reached in the particular location, the list of nodes that are generated from it. So these are all the four information that should be required for solving in the R graph. A graph employing this description is called as an R graph. You just note it down. This is for an R graph, and for this process or for this algorithm validation, if you are going to verify the two different that is two different lists. One is it consists of the nodes that have been generated, and here we are using some heuristic function is already applied. So, but not yet examined. So we can easily map with there is the node entries with the help of the priority queues. So we can do this, and the priority queue consists of the nodes are the elements with the highest priority, and this is mainly depend on the heuristic function that is associated with the cost with the node, and hence the prioritize of them. So this is called as an open list, and the closed list means what is it contains the node that have already been examined. For example, there is when the node is generated, then it is required to check whether it has already been generated. So we just note it down. And so how we are going to evaluate the performance or evaluation of the procedure? The f of n is the function can be defined as a sum of two elements. The cost of reaching from them from the initial node to the current node. So there is g of n is the additional cost that should be getting from the current node. So here the goal state that should be reached with the g of n plus h of n defined function. So we just discussed with the breadth first search algorithm. So the breadth first search algorithm. So what are all the and the algorithmic steps can be used? There is first one is we just assign then here we are using so many steps. First one is initial state or the node that should be assigned with the open list. So this is the first one. Another one more thing is do till the goal is found, or no nodes in the open list also. So how we are going to do that? Another is here we just note down the select the best node. Since the priority queue is used, that is possible from the open list, and that should be added to the closed list also. Another one more thing is second one thing is generate the successors. This is the second one, and third one thing is for every successors do, if the successor is already generated, and change the parent if this new path is better than this earlier one. So accordingly update the cost to this node as well as to the previous successor if any. So if the successor is not generated previously, then evaluate it on the basis of the heuristic and add it to the open list and make a note of its parent as well as. Okay, so you just note down this. So this is for every successors. For every successor, if the successor is already generated, change the parent. If this new path is better than this earlier path, so we just update the cast to this node as well as the previous successors. And if the successor is not generated previously, then evaluated the is based on the basis of the heuristic function and add it to the open list and then find the list also. So this is a algorithmic part for representing the best first search. Another one more thing is this is an example. So how we are going to find out the solution for this. Okay, so these are all the nodes. So this is a one simple the best the simple graph. So we are able to find out the simple best first search. So how we are going to do this now? So we just note it down here. 1, 2, 3, 4, 5, 6, 7, 8, 9 nodes are there. Each and every nodes that should be associated with this the heuristic function. So S may be 10, A is 9, and B is 7, and C is 8, and D is 8, and H is 6, and F is also 6, and C is also G, and 3, and H is also 0. So we are able to find out the path from source node S to the destination node is H. So how we are going to find out the solution for this? So in the first step, you just note down this one from this state S. So you need to find out the successor of the S. So in the from the successor of the X, you may have the three different successors. One is this A and B and C. So open and closed. So open means yes. So yes may have the three different successors A, B, C. So 9, 7, 8. So we need to find out the very minimum value that is called as in here we are taking the value as 7 here. So now the node S comma B is closed now. So again I just take the node as B. Again I want to open the node as B. We need to find out the answer for this. So here we need to have, and for considering the node B, we may have the um, two different node structure, that is D8 and H is equal to 6. So which one is very minimum when compared to H is equal to 6 and D is equal to 8? So H is equal to 6, that should be a very minimal node. So you just consider that aspects. So 6 is very minimum. So you just take down this one. And so after this you may able to find out, and now the S comma B is closed now, and again the node H is open now. So again for this node you need to find out the successor of the node. So once the node is open, so you need to find out the successor, and based on the heuristic function we are able to choose the node along with their the heuristic functions also. So H is equal to 6. So for considering the node H, we may have the two different option. One is this F and G. Another one more is F and G. So we need to find the minimum value is that is F is 6 and G is also 3. So we just take it as G is very 3 1. So you just note it down. And now SBH is closed now. So the node G is open now. So from this node, you may have only one successor, that is called as an H is equal to 0. So you just take it as H is equal to 0. So you may have the option S, B, H, G, and H. Okay, so you may have the option as S, B, H, G, and G. So you are H1. So you just note down that kind of the things also. So this is an H1, or sorry, not H1. This is I. This is also I.